the college physics textbook, volume 10, page 187, number 38. The question is, two shuffleboard discs of equal mass, one red and one green, are involved in a perfectly elastic glancing collision. The green disc is initially at rest and is struck by the red disc, moving initially to the right at 5 meters per second. After the collision, the red disc moves in a direction that makes an angle of 37 degrees with its initial direction. Meanwhile, the velocity vector of the green disc is perpendicular to the post-collision velocity of the red disc. Determine the speed of each disc after the collision. So right off the bat, we already know that since it's a perfectly elastic collision, the kinetic energy is going to be preserved, and since the red, okay, so the red disc is here, and the green disc is here, and the green disc is initially at rest. After the collision, though, the red disc hits it, causing the red disc to go this direction of 37 angles. And since it said that the velocity vector of the green disc is perpendicular to the post-collision velocity vector of the red disc, and perpendicular means it intersects at a 90-degree angle. The angle of which the green disc moves is 53 degrees. Momentum is calculated as P is equal to mv, where P is momentum, m is mass, and v is velocity. To start off the problem, we have to break it down into two components, in the x direction and the y direction. So the initial momentum in the x direction could be determined by mv, r is for red, plus mv, g for green. And since we know that the green disc was initially at rest, we could cancel that out. And since they are both have the same mass could also be excluded. So the momentum initially in the x direction would be 5 meters per second. And we know this because it was one of the givens. And momentum initially in the y direction is 0 because there was no mass or velocity in the y direction. Since it was a perfectly elastic equation, we know that momentum was conserved, so the momentum initial is equal to the momentum final. So we could set it up as 5 is equal to mvr cosine theta, since it is a vector quantity, plus mvg cosine theta. And that could be expressed as, well, once you plug in the numbers, mvr cosine 7 plus mvr cosine 57. Just to clarify, we have 5 is equal to mvr cosine 37 plus mvg cosine 53, and we're looking for the velocity of the red disc. At the final momentum in the y direction, and that is equal to mvr sine 37 minus mvg sine 53. And since the initial momentum in the y direction was 0, it's going to be mvr sine 37 minus mvg sine 53. And we neglect the mass since they're equal. So now we have 0 is equal to vr sine 37 minus vg sine 53. And we want to get velocity of the red disc alone. So we're going to add it to both sides. So we get vg sine 53 equal to vr sine 37. And to get the velocity of the red disk alone, we're going to divide by sine 37. 53 over sine 37 could be evaluated as 1.33, and that could be put back into the equation that we found for the final momentum in the x direction. So when we put it back in the equation, we get 5 is equal to cosine 37 times 1.33 v, which is equal to VR, plus cosine 53. So we get 5 is equal to 0.8 times 1.33 plus 0.6. And when we evaluate that further, we get 5 is equal to 1.664. And we would solve it even further. We get that the velocity in the red disk is 3 meters per second. So this is the equation we're going to use to find the velocity of the green disk. And since we already found the velocity of the red disk, we could plug that in. And we get the velocity of the green disk is equal to 3.999, which you can round up to 4 meters per second. So the final answer is velocity of the green disk is equal to 4 meters per second, and the velocity in the red disk is equal to 3 meters per second.